Hello everyone, my name is Ayush Singh, pursuing BE from Sri Venkateswara College of Engineering, and today in this video we will be talking about corrosion. Corrosion. It is defined as the destruction of metals or alloys by the surrounding environment through chemical or electrochemical reaction. It may occur either in a dry environment or in an aqueous medium. The former is called dry corrosion and the latter is called wet corrosion. Dry corrosion. It is also called chemical corrosion. Dry corrosion involves the direct attack of metals by dry gases, mainly through chemical reaction. It occurs by direct attacks of atmospheric gases such as oxygen, hydrogen, sulfide, halogens, and sulfur dioxide on the metal forming oxide layer. As we can see in the picture, it is a decolorization of the metal. In dry corrosion, it is also happens the same. For example, the attack of dry air, oxygen on a metal to form an oxide layer over the surface. Some prevention methods can be applied to prevent dry corrosion, such as applying protective coatings, using corrosion-resistant metal or alloys, employing corrosion inhibitors, and implementing proper maintenance and cleaning practices. Wet corrosion. It is also called electrochemical corrosion. In wet corrosion, it is an electrochemical process that occurs when a metal comes into contact with a conducting liquid such as electrolyte. This electrolyte allows for the flow of electrical current between different areas of the metal surface. Wet corrosion is a more rapid and destructive form of corrosion compared to dry corrosion. For example, rusting of iron nails and corrosion of underground pipes. As we can see in the figure, it is an wet corrosion actually of underground pipes, which is actually deteriorated. Some prevention measures can be applied for preventing wet corrosion, such as applying protective coatings and using corrosion resistant materials. Corrosion and its type. There are several types of corrosion. First one is differential metal corrosion or galvanic corrosion and differential erosion corrosion. There are two subtypes of differential erosion corrosion, which are alkaline corrosion and pitting corrosion. We will be talking about these types of corrosion in the upcoming slides. Differential metal corrosion or galvanic corrosion. In galvanic corrosion, two metals having different composition are in a contact with a corrosive conducting medium. The metal with lower electrode potential acts as the anode and undergoes oxidation, leading to corrosion. The metal with higher electrode potential acts as the cathode, undergoes reduction, and is protected from corrosion. For example, steel screws in or bronze equipment and steel pipe connected to copper plumbing. In the figure we can see also the bolt is mostly rusted as it undergoes corrosion, and the nut is unaffected from the corrosion. Differential erosion corrosion. In differential erosion corrosion, it is a type of corrosion that occurs when oxygen concentrations vary across a metal's surface. The varying concentration of oxygen creates an anode and a cathode on the metal's surface. The part exposed to lower oxygen concentration becomes anodic and corrodes. The part exposed to higher oxygen concentration becomes cathodic and remains unaffected. For example, partially filled iron tank undergoes corrosion inside water and standing water in a gutter system. Similarly, in this figure also we can observe that the metal tip that is under the water is undergoing corrosion, and the metal part that is exposed to more oxygen does not go under corrosion and it's unaffected. Waterline corrosion. When an iron rod is partially filled with water for a long time, the inner portion of the iron rod below the waterline is exposed only to dissolved oxygen, whereas the portion above the waterline is exposed to more oxygen. The portion below the waterline acts as anode and undergoes corrosion. The upper portion acts as cathode and is unaffected. A distinct water a distinct brown line is formed just below the waterline due to the deposition of rust. For example, tips which remain partially immersed in the water for a long time. In this figure, we can observe the waterline corrosion which is going to happen is just below the uh, liquid, which is electrolyte solution present in this, and the metal part which is more exposed to air or which is not in the electrolyte will not go undergo corrosion. Heating corrosion. In this type of corrosion, it is observed that when dust particle, oil drops deposited over the metal surface, heating corrosion results when the portion of the metal covered by dust which is less aerated becomes anodic and undergoes corrosion and form pit. The remaining area of the metal is exposed to higher concentration of oxygen, becomes cathodic and remains unaffected. In this figure, we can see the area which is Fe. We can the brown part we can see it's going under pitting corrosion because it's less exposed to oxygen. So the pitting corrosion or the corrosion will start from there, and it will spread throughout the metal surface as time goes. Okay, that was all for this video. Thank you.